Hi everyone, welcome to Lesson 2, describing features of functions, domain, range, and continuity. In algebra, we learned about relations and functions. A relation is a set of ordered pairs. A function is a special kind of relation. It's a rule that maps each input to exactly one output. Here's an example of a mapping diagram that represents a function. Each input is mapped to exactly one output. It's okay that we have two inputs mapped to the same output. That's allowed. What's not allowed is to have an input that's mapped to two different outputs. So in this mapping diagram, we do not have a representation of a function. We would call this a relation, but it's not a function. Let's review what we mean by domain and range. The domain of a function consists of all the values that we are able to input to the function and get an output. The range of the function consists of all the values that can possibly come out of the function. We can visualize this match of domain values with their associated range values with a graph. The graph of a function y equals f of x is the set of all points x comma f of x with x in the domain of f. So if you take all the points that you get when you plug x into the function and you get f of x out, that gives us a graph. The ordered pairs that yield the graph are formed by matching the domain values along the x-axis with their range values along the y-axis. So here's a point on this graph. Every single point on the graph has the coordinates x comma f of x. So no matter where you are in the graph, if you plug in the x value, the y value is equal to f of x for whatever x value you plugged in. Here's an example. This is the point 2, 12.5. So 2 is the domain value, or the input, and 12.5 is the range value, or output, that we get when we plug 2 into the function. We have f of 2 equals 12.5. When we plug 2 into the function, 12.5 is what comes out. We could also write the value of the function at x equals 2 is 12.5.